Alright, so today we're gonna show you how to make the L-Cheapo version 2.5. Now this is the L-Cheapo 2.5 board, and you can see it here. It's our own design, and to save time I've already soldered the resistors on it. So for a 2.1 laser you need 8 resistors on it. For a 3.5 laser you need 13 resistors on it. As you can see, they go in between the big contact in the middle and the other two. It doesn't actually matter which holes you use. In this case I alternate holes because I want some air to be able to go through them. The resistors also act as a way to passively dissipate heat. Now this is the LM338. So what you gotta do with this guy is that it's important that it conduct really well with the thermal plate here. So that means we're gonna need a lot of solder, big soldering iron, the kind you use to do pipe work, and then you have to get, I don't know, small screwdriver or something, and you in the hole of the LM338. I don't know if you can see it from here. In the hole of the LM338, you put a bunch of solder, like so. Now don't be afraid, you will not damage the LM338 thermally. These guys are tough. So you want to cover the whole of the LM338 entirely, like so. And then you use the remainder of the solder and the screwdriver to push the LM338 down on the plate, and then you make sure you have a very good connection between the plate and the regulator. The reason for this is not to transmit power, it is to transmit heat. You want to have a very good thermal connection. Now this is very important because this is what allows the laser to function for long periods of time without burning. So this is what it should look like when you're done. The next step is you have to regulate the voltage regulator. This is in LM2596. You regulate the voltage regulator with a screw, and it must say 8 volts. Now that's a bit of a weird voltage, but it should say actually just slightly under 8 volts. 7.9, 7.8 is fine. Then you use the legs that you've saved from the resistors. So these are the little resistor legs that came off this, and you put them on these 3 connectors. 1, 2, and 3. Note that this one is on the side a little bit. This is to make it easier to mount the heatsink later. I'm gonna move this thing so that you can have a better view. You can see what I'm doing here. These 3 legs should stick out a little bit. Now you can use the big soldering iron or the little soldering iron for this one, up to you. and you should have 3 legs sticking out. And these are normally stuff, these are the leftover legs from resistors. You would normally throw them away. So let's not waste things. This is even in view. Move it to the middle a bit. There we go. Now, importantly, the lowest leg, you want to put some extra solder on the pad. It will become useful later. Let me see what we're doing here. Yes, we can. Okay, good. Note that although the 2596 has 4 connectors, we're only using 3. Now that's no accident. It's done for 2 reasons. 1, to make the thing a little smaller. 2, to force the return to ground path where we want it. And actually the other reason is that this way, if you happen to solder it backwards, it will not self-destruct. It will just sit there and not work, which is never a bad thing. Okay. Now we've got the 3 legs mounted. As you can see here. We put the back module in, and we want the coil to be at the top. Note that we are not using the ground in. So when you solder this, you want to leave a bit of distance between the boards. For this one, I strongly recommend using the small soldering iron. Let's get this guy out of the way for now. Again, make sure that the board has a little bit of clearance compared to the main board. And then solder away. The clearance will also allow you to use the prototyping area should you ever require it. Now note that this one, the leg bends, and this is mostly to make sure that there is no risk of this contact touching the heatsink, which would be bad. This is what it's supposed to look like at this stage. Note that you can kind of lift this and you can bend it back in. That will come in handy later. For now, let's cut the excess wires. Next, we have to install the transistor. This can be any hex FET. Note that the board has little letters on the back. It says G, D, and S for gate, drain, and source. And this actually tell you how to mount the transistor. You mount it on the back here. You can either fold it or you can hold it in this direction if you prefer, depending on which way you want to have it on your laser. See, a problem with this board is that it's not very easy to assemble automatically because it has components on both sides. And you solder the transistor in. Should look like this. Make sure that contacts do not touch. Remove the extra parts. Now it's time for the resistor. This is a 100,000 ohm resistor. The power resistor are all 5.6s, 5.6 ohm. The resistor goes between the square vias. You can see them here and here. They have a square side to tell them apart. The resistor can go either this way or on the back, depending on how you want it to look. I want it to go on the back on this one. This resistor's job is to make sure that the MOSFET does not turn on when there is nothing connected. For this job, you would probably want to use a small soldering iron. And there you go. Then you take a small wire. This is your control wire. It is used to turn the hex FET on and off. It can also be used at low frequency for pulse width modulation. You tin the tip. This one goes right above the terminal on the resistor that is not on ground. So this one, next to the big hole. You probably want to put in this way because that lets you use the big hole as mechanical relief. So you want to do the soldering on this side. You have to use a small iron for this. There we go. And we'll remove the extra leads. We will not need these again. By the way, if you do not want to use the TTL connector, you just tie it to the positive lead. Next, we have protection diode. The protection diode makes sure that if the customer connects this thing backwards, it will not fry itself. You would think that will not be a problem, but it occasionally is. The thing is, most 3D printers do not have clear indication whether their extruder heater has polarity. So this allows people to do trial and error. So this goes in this way. Note that the cathode is going what is normally not the traditional direction, but we have to fit it this way. So you bend this and you fit it between the two large holes, like so. And then you solder it. Remove the extra leads as usual. They should look fairly clean. Note that the heatsink on the hex FET will not get hot because these hex FETs are very over-dimensioned. They are 60 amps and you have less than 3 going through them. Next, the fan. Now this is also our power lead. So you take about one side and a little bit more, one side and a half, cut the leads. So that's the fan, and these are the power leads. The power leads go where it says plus V and minus on the top of the board. Again, you will use this hole in the center for mechanical relief. This setup is somewhat convoluted. It requires using a protection diode, a voltage regulator, and a current regulator, but it allows a wide variety of voltages. There we go. Now we have these three wires, power, ground, and activation, and we send them through this hole for mechanical relief. If you want, you can, do a turn, but I have found that to not be generally necessary. These can be connected to a number of things. You can use a normal servo connector, for example. Again, if you decide to not use this lead, all you have to do is connect it to the positive lead and use whatever PWM your 3D printer or CNC router already has. Next up, the fan leads. You will see on the board that here there are letters. It says plus F, in the middle it says minus, and here it says plus L. Obviously F is fan and L is laser. Now you lift this a little bit. This should give you room to solder the wires in the appropriate position. Make very sure that the leads do not short each other. Now, this is the circuit. Now it is time to assemble the laser block. This is the M140 laser diode. This is a TO220 heatsink. We're going to make a bigger hole for it and then ream the diode inside the heatsink. For this purpose, this instrument has been made. This is a hand drill with a simple instrument used to keep the angle for holes. This is used in carpentry. This stuff costs $10. We have 3D printed a socket for the heatsink to make sure that it fits properly. The diameter of this will vary according to what brand of this part you buy. Insert the the heatsink in the socket. It should have been somewhat tight when it was printed. And use the hole that already exists as a pilot hole. You may find it necessary to screw the bit in a bit better, like in this case. However, it is important that this thing be jiggling a little bit because this bit is just a little bit too small. So therefore, you must give it a little bit of freedom of movement. Drill through slowly, don't push in too far. Once you are done making the hole, let it play in there a little bit. You need to widen it just a little. At this point, this is going to be hot. So don't use your finger to remove it. It will be a little hard to remove because it will have expanded thermally. The front should be undamaged. If there's a crack in this, it means you have to use a different one. Next up, using a heavy-duty vise, we have to ream the diode in. Insert the diode. Make sure that it is sitting vertically. And then put it in the vise. Again, make sure that all the parts are sitting at the angle at which you want them, because once this goes in, it goes in. You cannot adjust it later. Take your time. Give it small adjustments. Note that this vise had a corrugated front. It has been flipped because we do not want to damage the copper holder. Now this is important. This must be done with great care. Slowly and deliberately ream the diode holder in. Until all the screwable part is visible. This is what gives you the best heat transfer. Let it sit for a bit, jiggle it a bit. Just make sure that this is at the right angle. Then remove it. This is how this is done without damaging the very delicate glass inside the diode. If you want, you can now screw in the cover. Now this is necessary for 3.5 watt lasers, but optional for 2.1s. The leads are visible and it should screw in properly, like so. And this part is optional. Next, you will have to insert the spring that keeps the lens in place. Then the lens. Note that this side is slightly concave while this side is flat. Use the concave side to make sure that the spring also stays in its place. Finally, screw in the crown. This is the laser assembly. It's extremely important that good thermal conductivity exists between this part and this part. Use the guide holes. They will be tight. This is intentional. If these do not come in quickly, you will want to use a wrench to squeeze them together. Do not solder these yet. We have to test the diode first, which means we have to connect it. Cut this lead to fit. Give yourself a little bit of room while you do. Then, with a small soldering iron, tin the tip. Finally, you can insert it in the two holes that we have not used yet. Note the order of the wires. We have red, black, black, red. One thing that is important is that in this design, the large metallic part, the heatsink, is not ground. This is what it has to look like. Red, black, black, red. Lift this again and solder it in place. Make sure that there are no shorts. If there is a short, it will not damage anything, but it will not work when you test it. Now it's time to test. I will now go and get my protection glasses. Alright. The protection glasses will not protect you from a direct hit. Don't do this, ever. You will lose an eye. But they will protect from reflection, which is what they have to do today. Make sure that you're not aiming this at anything particularly important or interesting, such as cell phones, cameras. I'm aiming it at the wall. And then we power it. Now this is a 12-volt setup from a ATX power supply. Connections are as follows. black to ground, red to yellow +12, and then the TTL activation will go on red to simulate the TTL. If you have done everything right, the fan will spin and the laser will turn on. That seems to be the case. Now you can solder these in. Make sure that this is nice and horizontal. Push down on it if you have to. And then with the big iron, solder the leads in. This is not electrically necessary, but it will improve thermal conductivity. Don't be stingy with the solder. The solder's job is to move heat around. You want a lot of it. Finally, you take the 3D printed body for the laser and you insert the laser into the mount. There is a guide for it. The last step is to take the fan like so. It needs to push downwards clearly. And using 2 zip ties, fasten it to the body. You insert the zip tie this way. Go into the upper hole. Repeat on the other side. And then insert into the screw holes for the fan. And finally, you close the zip tie. Don't tighten it yet. You tighten them at the last moment at the same time. There we go. Now you tighten it. Make sure that this is nice and horizontal. We have seen how to assemble a L-Cheapo 2.5 in 2.1 watt configuration. This has been a Robots Everywhere instructional video. We sell this thing, and if you don't want to buy it from us, we have the schematic and parts list on our website. Remember, always wear protection glasses. They will be either orange or green. The protection glass will not save you from a direct hit. You can connect this thing to your extruder heater and turn it on normally. Note that there is no extra box to have. This is self-contained. If you want, you can use this for pulse width modulation control. If you do not, you can simply connect the gray or white wire to the red wire. Connecting this backwards will simply have the effect that it will not work. You can swap the terminals and try again. That's what the protection diode is for. This will work with all voltages from 11.1 to 24. And that's the end of the video. That's how you make a laser. This has been Matteo Bari for Robots Everywhere.